So what a way to kick off the course. What you're looking at is a photograph taken by the Hubble Space Telescope, and those like little specks of light, those are actually galaxies. We'll be talking more about galaxies, but galaxies are their own little set of, we call it a little island of stars. So good chance you have a concept of galaxies. Those are far away. So it's just amazing. Let's see. Out in chapter 1 by talking about different objects in the universe, and we'll start out kind of close to home. This is a kind of a glance at the solar system. You see here in the middle we kind of have tight terrestrial rocky planets, and then going out then we get the gaseous planets, and then we have another rocky object, actually rocky icy object, that is no longer classified as a planet, of course, Pluto. So one of the things that, if you've been watching the news, you know that actually we're seeing that most stars have planets, which is kind of fun. So this image you don't have in your PowerPoint packet, but what I did was go out to, and I'm going to kind of make it big so you can see, there's a very nice website out there called heavens-above.com. And so what this image does is show you, it was taken a couple days ago when I got off the internet, but it shows you the exact location of these inner ones right here are the 4 rocky or terrestrial planets. Okay, so of course here's the Sun, then we have Mercury, Venus, Earth, and Mars. So honestly, it's kind of what we call the configuration of the planets that shows, this is us, that dictates kind of where we're going to see that planet in the sky. So I'm going to go ahead and shrink that down. And then this image is showing the outer planets. Let's see if we can see those. Here we have Jupiter, Saturn, Uranus, Neptune, and Pluto. So kind of at a glance, our solar system. Like I said, we're seeing that most stars have planets. We'll have a whole chapter devoted to the Sun. The Sun is just a kind of an average, what we call G-type star. And so I'll kind of highlight this image over here. It's not the best image, but I think what's trying to be emphasized here is these are like what we call sunspots, like little blotches that come and go. And these actually is a sunspot group. This right here is a close-up. We'll come back. This right here is a close-up of a sunspot. And if I could animate this region right here, you would see these granules kind of via kind of what we call convection, hot blobs of the sun come up and then fall down in these little granules. So it's kind of cool, kind of creepy looking. The sun. The sun's an awesome object in and of itself. The thing about astronomy is, I mean, it's so rich in, oh, that's awesome. And so it's so rich in, oh, that's complicated. If you've ever heard of coronal mass ejections, that's actually when the sun kind of, I say kind of burps or bellows material. And that's kind of what this, to me, kind of reminds me of. We have coronal holes, and that's kind of like what we might have here. Then this slide over here is just to kind of give you a preview. One of the things that we're going to talk about is the fact that the sun actually goes through 11 years. It kind of peaks, gets rambunctious, and then it kind of dies back down again. So the sun actually has been in the news recently because of its inactivity. The what we call the solar max wasn't as large as they were thinking it was going to be. Taking a look at the planets now. I have some pictures of a couple of the rocky planets. Here's Mars, gorgeous Mars, and we'll be talking more about this feature right here. If you visited the Grand Canyon, this is like a Grand Canyon on steroids, and but it's like it's a canyon, and it's kind of near the equator of Mars. Mars is just a really happening spot with regard to, rovers roving on it, and like satellites going about it. I mean, it's just a really, happening place. And then over here, come back. Over here we have one of the gaseous planets, starting with Jupiter, Saturn, Uranus, and Neptune, they're gaseous planets. And one of the things I'll try to kind of point out when we look at Uranus is, can you see, does it look like it's kind of tipped on its side? Because over here, you see the rings, okay? So it looks like its axis of rotation is here, and actually Uranus is like that. But one of the things you can see on this slide is some text with regard to the definition of a planet. So not to get too dramatic about it right now, but actually back in, I get my dates mixed up, but back in around 2006, finally, folks had to go and visit what is the definition of a planet. And it all had to do with the fact that an object that is farther away from the sun than Pluto, all right, I'm going to the demotion of Pluto, an object that was farther away than Pluto from the sun, but orbiting the sun in a region called the Kuiper Belt, it looked like it should be another planet. And so like, hey, wait up, we need to go ahead and, do we really need to make that the 10th planet? That object was Eros. And so you probably know what came of all of this new definition of a planet. Okay, this defining a planet. It was never really defined in the first place. This defining of a planet was the demotion of Pluto. And I believe we're going to talk more about it later. But the thing about Pluto is that it failed number 3. It fails. Pluto is spherical. Pluto orbits the sun, but it has not cleared its orbit of debris. More on that later. All right. So the other thing, just kind of in general about all planets, is that, and maybe you already know this, but I just am amazed when I think of, when you look at a planet in the nighttime sky through a telescope or just your naked eye, you're like, oh my gosh, that light that you see from the planet actually came from the sun. Okay, that light came from the sun. It hit the planet, and then that light reflects off the planet back to us. So I'm just amazed. But I'm easily amazed, some would say. Okay, so some photos here of a couple of other rocky planets other than Mars. We have the planet that is closest to the sun is Mercury. And if you think Mercury kind of looks like the moon, it does. It's kind of got that gray kind of pocked mark, kind of like our moon. But this is Mercury. And over here, this is Venus. This is actually, if it looks kind of fuzzy, that's because actually it's covered in clouds. Even though it's rocky and you could stand on Venus, just like you stand on Mercury, Mars, and the Earth, it's covered with clouds, and it's got like a weather cycle or a precipitation cycle or a cloud cycle, but that's sulfuric acid. So kind of that fuzziness you're seeing is actually from those clouds. And the fact that this is actually taken in the ultraviolet region of energies. So one other thing before I leave this slide is to point out that actually these two planets, Mercury and Venus, because they orbit our sun in tracks that are closer to the sun than the Earth's orbit or Earth's track. Okay, when we look for these planets, we're only going to see them near the sun, only near the sun. So what that means is we're only going to see them near sunset or sunrise. So what else we got? In our solar system, some planets have moons. Okay, this actually, it may look kind of like the Earth's moon, but this is a moon that orbits Jupiter. And this is one of the moons that Galileo saw with his telescope. Isn't that cool? And so actually there are 4 moons that Galileo saw orbiting Jupiter. And so out of respect, we call those 4 moons, generally speaking, Galilean moons. And so this is Ganymede, one of the 4 Galilean moons. So but just in general, we call anything, objects that regularly, due to gravity, orbit a planet are called satellites or moons, but not all planets. So this is the Earth's moon, and it's kind of a different look than you might be used to. This over here, okay, this side over here might look more familiar than this side over here to you. I'll put a question mark over here. Okay, I'm going to try to explain this later, but this here, same side we see. Well, that's kind of broken English. But this over here, this earth side, we sometimes call the near side. Oh goodness, I need to get me something to write better with. But this is actually the only side of the moon that we see. We do not see this side of the moon. Now we have seen that side of the moon because we've you know, been in orbit about the moon. And I'll try to show you why that is later. But let me go ahead and tell you just a little bit why that is now. The reason that we only see one side of the moon is because as the Earth, as the moon orbits the Earth, it also spins on its axis, so it the same rate. So it's called synchronous rotation. Okay, we looked at Mars earlier, but here's another picture of Mars. Very pretty. I mentioned rovers, and NASA's rovers in the news would be most recently Curiosity landed on Mars, a very exciting landing. It's been, gosh, has it been 2 years? But prior to Curiosity, Spirit and Opportunity were on Mars roving around, and Spirit has since got stuck, I think, and Spirit's not working, but Opportunity still is. So there you go. And this right up here may be catching your attention, okay? And that actually looks like a polar cap, and it is a polar cap, but it's not water. It's not water ice. It's CO2 ice. All right. Between Mars and Jupiter, but what's between Mars and Jupiter is pretty important, called the Asteroid Belt. But here are some pictures of what comes after Mars with regard to planets. So we have the first gaseous planet, Jupiter, and one of the features a classic feature of Jupiter is the Great Red Spot, apparently getting smaller. Less great, I don't know. And not my favorite picture of Saturn, but here's Saturn. All of the gaseous planets have rings like Saturn, but Saturn's are most remarkable. Planets. Okay, I mentioned that Uranus is kind of tilted on its side. There's Uranus, and there's Neptune. 4 gaseous planets. Not a planet anymore, but it is what we call a dwarf planet. Okay, you just have to insert the word dwarf in front of it. Okay, so after the definition in 2006 of what a planet is came out, Pluto failed that definition, and then related to that, it's a new class of objects called dwarf planets. I don't know if that was already there or not, but anyway, Pluto is a dwarf planet. And if you can see Charon over here, Charon is one of Pluto's, I want to say that now we know that Pluto has 5 moons that orbit Pluto. The thing about Charon, though, is if you read about it, Charon and Pluto are very similar sizes. Charon is smaller, but not much smaller than the object it's orbiting. So they kind of, what we say, share a common center of mass. All right. So now I'm not going to go to this website, but I just want to make you aware that this little dwarf planet is so important that it has a spacecraft on its way to have a close flyby of Pluto. We don't have any very good photos of Pluto, so we will soon. New Horizons, check it out. And here's a figure from your textbook that just kind of, not everybody's necessarily been to Washington, D.C. and been on the mall and kind of have a sense for how long that is. But one of the things I guess I would emphasize, and we'll look at it closer later, how big is the sun relative to the planets that are in orbit about it. But it's pretty darn big. And so just in general, if the size of the sun were a grapefruit, okay, then the size of the Earth would just be the tip of a ballpoint pen. And specifically kind of drawn to scale, that the Earth would be that small, and it would be about 15 meters away from the grapefruit sun.